In this video, I'll be discussing ISO FIT system. ISO, the International Standard Organization, has laid some guidelines to determine the system of fits. The shafts and holes are toleranced by ISO coding system. So there are two basic types of ISO fit systems. One is the shaft bias fit system and the other is the hole bias fit system. First, I'll be discussing the hole bias fit system. In case of hole bias fit system, we will use a basic H hole. The basic H hole is shown in the figure. For the basic H hole, the fundamental or the lower deviation of the hole is zero. Or we can say that the lower limit of size of hole is equal to basic size, as can be seen in the figure. The lower limit of the size of hole is equal to basic or the design size. And the tolerance zone is extending upwards from the zero line. The zero line is the line corresponding to the basic size. Once we have determined the basic size and the tolerance interval of the hole, the fit will depend on the fundamental deviation and tolerance zone of the shaft. So depending upon the fundamental deviation and the tolerance zone of shaft, we can classify the fit as the clearance fit, interference fit, or the transition fit. So as can be seen, the shafts are designated from 1 to 7 according to their tolerance zones. So for the shaft designated as 1 and 2, we can see that the upper limit of size of shaft is less than the basic size or the lower limit of size of the hole. So when the shaft 1 and 2 will be mated with the basic H hole, it will result in clearance fit. Similarly, the shaft designated 3, 4, and 5, the tolerance zones of shafts and holes are having a degree of overlap. And when there is an overlap between the tolerance zone of shafts and holes, it will result in transition fit. The actual fit between the shaft and hole might be a clearance fit or an interference fit depending upon the actual sizes of the shaft and hole. Similarly, the shaft 6 and 7, we can see that the lower limit of size of shaft is greater than the upper limit of size of hole. So this will result in interference fit. With the minimum interference greater than or equal to 0 for the cases 6 and 7. So now this is the figure taken from ISO 286 of 2010. So here I'll discuss the hole bias system in detail according to the ISO coding. So here we can see the red line is the line corresponding to the basic size or the zero line. So we will use the H hole in case of the hole bias system. And for the H hole, we can clearly see that the fundamental deviation is zero, or the lower limit of size of the hole is zero, and the tolerance zone is extending upwards. Now we can see the different fundamental deviations of the shaft from A to ZC. For shafts designated with A to G, the upper deviation will be the fundamental deviation and it is negative, as is shown by the red arrow. Similarly, for the shaft H, the upper deviation is zero and the tolerance zone will extend downwards. Now, if we mate the H hole with shaft designated with A to G, it will result in a clearance fit with the minimum clearance. It will have some minimum clearance. Whereas if the H hole is mated with the H shaft, the minimum clearance will be equal to 0, but it will again result in a clearance fit. So the clearance fit will occur when the H hole is mated with shaft designated from A to H. An example is 20H7C6. Here 20 is the basic size in mm, H7 is the fundamental deviation as well as the tolerance grade for the hole, and C is the fundamental deviation for the shaft, and C6 its tolerance grade. Now let's see the shaft designated JS. For the shaft designated JS, we can see that the upper deviation will be positive and the lower deviation is negative, and both are equidistant from the red zero line. Similarly, for the shaft designated J and K, we can see that the lower deviation is coming closer to the zero line, and the deviation which is closer to the zero line is also the fundamental deviation. So for J and K, the lower deviation will be the fundamental deviation. If we look at shaft J, the lower deviation will be negative. Similarly, for shaft designated K, if we see closely, we can see K1 to K3 and K8 to 18. The lower deviation will be equal to 0. If we compare it with the H shaft, for it the upper deviation was equal to 0. So for K1 to K3 and K8 to 18, the lower deviation is 0, and for K4 to K7, the lower deviation is positive. Similarly, for shaft designated M to ZC, the lower deviation will be positive. Now, when the H hole will be mated with shaft designated JS, J or K, it will result in transition fit. In fact, the transition fit extend up till N. Example is 20H6J6. So M as well as some cases of N shafts will also result in transition fit. And for shaft designated N to ZC, when they are mated with the H hole, it will result in a interference fit, and an example is 20H8P7. So that's about the hole bias system. Now let's discuss shaft bias system. For the shaft bias system, the fundamental deviation of shaft will be equal to 0. So in the diagram, we can see a basic H shaft. For the basic H shaft, the upper limit of size of shaft will be equal to the basic size, or the upper deviation of the shaft will be equal to 0. Or if we compare this with the hole bias system, for the hole bias system, we were using a H hole, and here we will be using a H shaft. So for the H hole, the lower deviation was 0, and for the H shaft, the upper deviation is 0. And the tolerance zone for the H shaft will extend downwards. Now, for the different shaft designated 1 to 7, we can see the tolerance zones. So, sorry, for the different holes. And depending on the tolerance zone of the hole, the fit can be classified as clearance fit, transition fit, or interference fit accordingly. So here we can see the shaft 1 and 2 when mated with the, the holes 1 and 2 when mated with the basic H shaft will result in a clearance fit. Similarly, the shaft, when the basic H shaft is mated with holes having tolerance zone as shown by 3, 4, 5, and 6, it will result in transition fit. Similarly, when the hole designated 7 will mate with the basic H shaft, it will result in a interference fit. Now this is again the figure taken from ISO 286-1. So here for the shaft bias system, here we can see the H shaft with its upper deviation equal to 0 and the tolerance zone extending downwards. When the H shaft will be mated with hole designated A to H, it will result in clearance fit. And when the H shaft will mate with hole designated capital JS to N, it will result in transition fit. And similarly, when the H shaft will mate with holes designated P to ZC, it will result in interference fit. That's all for the shafts and hole bias system. Thanks for watching.